first speaker of the morning is Richard Garriott. Richard Garriott flew to the International Space Station for 10 days in October 2008 aboard a Russian Soyuz rocket. I won't go into any more detail because he's going to talk all about that. I'm sure you've all either met him or talked with him this weekend because he's been pretty much like a speaker the entire conference. I'd like to introduce Richard Garriott.
No, actually, it is. That's pretty funny because I sort of have been talking to all of you all weekend. So hopefully, I'll think of some new things to tell you all this morning that we haven't already covered. And it's really funny because my first real exposure to SEDS, because I sadly went through school just before SEDS came into existence. But I know Peter DeVandas, one of the co-founders, very well because we've done a lot of these businesses together. But the first time I really talked to a lot of you all was at the ISDC 6 months or so ago, and I got to tell you, I was incredibly impressed then, and so therefore I was very excited to come here to talk with you all, or more of your body, so to speak, more of your members. And this weekend has solidified my kind of faith, confidence, and excitement about my association, my participation with you all. So again, I think you guys put on a fantastic conference already, and it's a fantastic organization. I'm thrilled to be here talking to you. So what I want to do is I'm going to take you a little bit on kind of the my journey to and through, and how I pulled off an opportunity to travel into space. I want to talk to you a little bit about what I accomplished with my flight into space, and why I don't like to call myself a space tourist, that I do call myself instead a private astronaut. And then I want to talk a little about the future of, or what I think the future of space is going to be like, and specifically the role I believe that all of you will be playing in that, or can play, and I hope you play in that. And you'll notice that my last few slides are going to be extremely lacking in artwork, and that's because I added them during other people's talks over the last few days. And they were just things that I wanted to respond to from other people, or things that came up in discussion with you all, that I thought I would like to circle back here at the end of the weekend and get a chance to talk about. So, at least for me, the journey that led me into space is probably a little different than most of my predecessors who have gone to space. I had a father who was an astronaut. He went up, as you can see there, on Skylab 2, as well as the 9th launch of the space shuttle. My mother, on the other hand, is a professional artist. And so she taught me how to do all different kinds of art, including make this, I've shown off my snake to a bunch of you guys over the weekend, this thing that I made when I was 11 years old that's permanently attached to my neck. And that kind of combination of high tech and art led me into my career in computer games, which I think of as the quintessential high tech art. And I was very, very fortunate to be at the right age, the right time, to get a chance to kind of ride the growth of that industry. And I was publishing games in the 70s before there were distributors for games, frankly, and so it was a fortunate bit of timing. And that's also funded, that success has really funded my my explorations of the world, you might say. And in addition to space, I'm similarly excited about exploring the deep oceans and the four corners of the earth. So for example, the same group of us that started organizations like X Prize Zero G Space Adventures, we also have a deep ocean exploration company that we take people down to Titanic and hydrothermal vents, which I've done on about 5 occasions. We have another company called Adventure Networks it's the only private company that operates on the interior of Antarctica, where I've gone on expeditions to hunt meteorites and bring back ice core samples and things of this nature. And but specifically, my journey towards space began really when I was a little bit younger than you guys, when I was told by a NASA doctor, who was kind of our family physician at the time, that I was no longer eligible to be a NASA astronaut. And prior to that moment, I would have never said when I grew up I want to be an astronaut, but when you're told, by the way, you can't be an astronaut, and your father and all of your neighbors are all astronauts, it's like being told you're no longer eligible to be a member of the club that your father and all your friends are in, which is pretty disappointing. And suddenly, it was really that day, I remember the day very vividly, where I walked out there going like, well, wait a minute, who are you to tell me whether I'm allowed to go to space or not? If I can't go with NASA, I'm going to have to build a civilian space agency. And at the age of 15 or so, that didn't seem like such a big deal to just go do. But by the way, it's really freaking hard. But and after a number of failed attempts, I met up with people you all know well, Peter Diamandis, who is the founder, one of the co-founders of SEDS, as well as ISU and Space Adventure Zero G, X Prize, etc. And that was the group that managed to pull all this off. And so last October, I became the first father-son, Americans who flew in space. I flew in space with Sergei Volkov, the first father-son Russian who shares that title too. I'm also the 6th private citizen to have flown in space. After me, Charles Simonyi went back for a second flight, and Guy Laliberté became the 7th individual, our 8th client, our 8th flight. But just because you can go to space and or want to, and just because you can afford it, still doesn't mean they will let you. Then there's another big hurdle in addition to all that is you have to pass medically. And if you notice the extraordinarily large scar I now carry on my belly, that is one of my mementos of my journey to space, because if you apply to be a NASA astronaut and you're not medically perfect, they just pass and go on to the next applicant. If you're one of the few people who wants badly enough to go that they're willing to pay their own way, they'd rather take your money than flush you out. And so, but if you're not medically perfect, they would be worried about you not surviving the trip. They want to make you as medically perfect as possible. And so in my case, I had something called hemangioma on my liver, where I had one of the 6 lobes of my liver had an artery feeding it, but no vein draining it. So it was overpressured, and in the case of rapid depressurization of a spacecraft, could represent an increased probability of internal bleeding, and therefore an increased probability of death. And so they made me remove it. So that was one of the pre-qualification things I had to do. And but I got to tell you, I spent about 9 months in Star City outside of Russia, learning all the systems on board the Soyuz. Every crewmate, every crew member has to know how to operate every system on board the Soyuz. Life support, navigation, radios, everything. And that's actually kind of fun, arcane knowledge to have. I can tell you, if you point out things on that vehicle, exterior or interior, I can generally tell you what they do, I'm qualified as an operator. And the same thing is true on the space station itself. They want you to know how to operate everything, so that at the very least you don't have to go knock on tug on everybody else's shirt sleeve to go, hey, I forgot how to operate the radio, can you help me do my task? So they really need you to be independent just from a productivity standpoint, but also from a safety standpoint. Everybody's got to know what to do in case something breaks or goes down or there's an emergency. And so, again, I'm a fully qualified user like any other astronaut or cosmonaut. We all pass the exact same classes, and that's kind of just a fun kind of piece of arcane knowledge to carry with me. I got to tell you, one of my least favorite parts about training out there in Star City was the food. It's odd to have pictures of your food, and I didn't start taking pictures of my food until I realized I was getting the exact same meal every meal of every day. And in fact, it always had the potatoes, a little bit of meat, and some either rice or noodles. And by the way, 3 of those are breakfast, and the only reason you can tell is because there's a hard-boiled egg beside the plate. And but otherwise, literally got the same meal every single solitary meal. But anyway, that's. But on October 12th last year, which is Columbus Day, a good day to go fly. I got to tell you, as fun as the training was, nothing beats the day that you wake up in the morning, you put on your own custom-made spacesuit, you climb out to a fully fueled rocket that is covered with frost because of all the cryogenic fuel on board. Any air coming nearby, it is condensing into fog, and the fog is just streaming down the sides of it down into the fire pit below. And where everybody else is getting as far away as they can, you and your 3 crewmates crawl up and squeeze down inside this incredibly tight Soyuz capsule, and go through a couple hours of checklists and light it up. And the ride up on a Soyuz, as I was telling some folks earlier, just a little while ago, is really an amazing ride in that it's quite unlike a shuttle ride, I believe. The shuttle has lots of vibration and noise and things of this nature. The Soyuz, and for that matter, the previous U.S. liquid-fueled rockets like Saturn and Saturn 1B, are extremely smooth rides and extremely quiet rides. I would describe it really as a strong and confident ballet move, just lifting you confidently and very rapidly up into the sky. So really a fantastic experience. One thing to mention too about kind of my first impression of space is really funny that as you all are well aware, orbital altitude or low Earth orbit is only about 250 miles up, which is frankly just not that far up compared to say the moon or something. And so it's funny. We finished launching, and in 8.5 minutes you go from sitting on the ground going 0 miles an hour to going around the Earth at 17,000 miles an hour. And then when the engine's cut off, the vehicle rolls over and just kind of free tumbles for a little while. And my first view when I looked out the window, I went, wow, we are just not that high up. I sure hope this is a perfectly circular orbit, or we're going to be re-entering here real soon. And but it was just, I thought it was just kind of ironic that my first thought was not, oh wow, how beautiful. It was like, wow, I hope they got this right. And we spent 2 days in free flight, on board the Soyuz, kind of matching orbits and altitudes and positions with the ISS, checking out our systems, making sure we were safe to go dock, and that's a picture of us approaching and docking the space station. Here we are inside the Russian segment. Over on the left, this kind of this is my workstation. This is actually my kind of flight data files. This is the window I use to do most of my work of Earth observations. A couple more of my flight data files, the cameras that I was using, all my mission patches and things. The ham radio is up here strapped on the wall. But basically right here is kind of where I did most all of my work. When they first came up to me and showed me like, hey, here's your workstation, I was like, where? This whole place is so cluttered. I had to like push things out of the way to make myself my little nook to go work in. And the whole station is that way. The floor, the ceiling, and the walls, everything is utilized to hold stuff. And and like I was mentioning just before I came up here, you can always tell who the beginners like myself are, because you tend to bump into things as you go down the hallway, and that tends to dislodge them. So when you get to the other end of a module, you'll turn around and you'll see all the debris coming down the hallway that followed you, and they have to go take it all and Velcro it back on the wall again if you can figure out where it went. And also on board, in the Russian segment, which is where we generally have all our meals, the galley was designed for 3 people, and there were 6 of us on board, and so you tend to use the 3 space very efficiently. So there was pretty commonly a couple of us sitting on the ground around the table, and a few of us floating on the ceiling around the table, so that we could all get access to what Mike Fink is using there is the water processor that is to fill up a drink bag. And yesterday I was talking to some of you guys about sleeping. Well, in fact, Mr. Kelly also was mentioning sleeping. And a lot of people like Mike Fink just loves to sleep in space. He just kind of literally hangs out and ties himself to a wall somewhere and fell asleep easily. I actually found it tricky also. And so I felt better when I was kind of bungee corded to a surface. And I always missed having a pillow. But basically you're camping out. I kept a flashlight with me and some damp towel, a little drink bag of water, and literally it just felt like I was camped out in a tent somewhere as you try to sleep here on the ISS. And from an engineering standpoint, if there was one thing I could redesign on the space station, it would be the toilet. And what I find really funny, and if at the end, and if we have some time for Q&A and you want me to tell you the going to the bathroom story, going to the bathroom in space is the most common question kids ask astronauts. But I can also tell you it's the most common question astronauts ask astronauts. And I can also tell you that the training that you get and the answer you get told by other astronauts in public or in private between astronauts is not the whole, real, true, horrible story. But I am willing to tell you the whole story, so if you're interested. And of course over there are just beautiful views up there. Let me tell you a little bit about some of the experiments that I did. I would argue that, because I was unfettered by what I'll call red tape of trying to take things up, basically whatever experiments I wanted to do, I was funding them myself so I could do it, means that I took on a much heavier scientific regiment as well as commercial list of activities than I think any other quote, professional, unquote, astronaut undertook for the similar period of time, and I believe I can make that case, well, to you right now, amongst other times. And so one of the things, in fact, I think from a monetary value standpoint, probably the most interesting thing I worked on was protein crystal growth, which is actually a science which has gone on for about 25 years. My dad had started something back all the way on the shuttle. The Japanese have a really nice protein crystallization lab that they send up periodically as well. But what's interesting is that most people who are doing it for what I will call fundamental science reasons. They're really trying to understand the physical process in great detail. So they send up very large, very heavy laboratories with very tight constraints, and they produce a very small amount of crystals. I, on the other hand, am saying I want to produce a very large number of crystals that fit a particular business niche need to help pharmaceutical companies develop drugs. And so we developed a process where we could take up thousands of sample tubes at a time under thousands of conditions in a very small container, and get data back that is of commercial value in a much higher quantity and quality at a much cheaper price. And I believe we pulled it off not only with my first flight, but we flew the same experiment with Guy Liberté here a few weeks ago, and also are getting great results. And so now we're in the process of starting to sell this to pharmaceutical companies. And to give you a little primer, so this is what they look like. These are little couple millimeter wide tubes with these little protein crystals that have grown in it. And what's relevant about this is that if you are a drug company trying, in fact, specifically if you think about the drugs that are currently used for fighting AIDS, all of the AIDS drugs are they work in a way that is similar to the method that I'm about to describe. Which is, if you are trying to stop a particular biological function, say a disease function, one of the new strategies that has been developed to do that is to create a molecule that will bond strongly with the protein involved in that anomalous biological behavior. To do that, you need to know one of the best ways to develop such a drug is to know the precise molecular structure of the protein. But that's very difficult to do here on Earth because protein molecules don't hold still very well. And so one of the best ways to get them to hold still is to grow a crystal out of them. But if you try to grow those crystals here on the ground, convection currents during the state phase change cause perturbations in the crystal growth. So you don't get high enough quality images when you diffract those crystals to see the position of hydrogen atoms where all the bonding takes place. But if you grow those crystals in space, you get bigger, much more pure crystals. You can bring them down to the ground. You can get very precise molecular structures. And pharmaceutical companies can use that to save years and millions of dollars off their drug development time. And so therefore, I believe this as a business is an extremely valuable thing to do in space. And unlike a lot of the government-funded research projects towards it, we designed it specifically for commercial application, and we're continuing to pursue it vigorously. Another interesting thing I undertook was a kind of a follow-on of my dad's work on Skylab. You know, the Apollo guys were all interested in going to the moon and back, and it wasn't until we had Skylab up that we began to do things like pay much attention to Earth observation. And the Skylab astronauts, including my dad, took some of the very first ever human photographic surveys of the surface of the Earth. And since I was flying 35 years after my dad, I thought, and I'm the first second generation American to do so, I thought it'd be useful for me to go back to the Skylab photo archive, data mine it for places I might go take pictures of, where we could showcase how the Earth has changed in 35 years and one generation of space travel. And the Nature Conservancy also was very interested in this. NASA, the Earth Observation Group, was very interested in it. We developed a new piece of software to do rapid targeting of Earth observation targets. This company called Turk that helped make that. That is now being sold back to NASA as NASA's primary method of target acquisition from Earth observation photography. So we got both excellent results with the data, as well as we've created excellent tools that are now being used globally by other astronauts and cosmonauts. And so just as a case study, here's a good photo of the picture on the left is my dad's Skylab era photo of the tip of Florida. On the right is mine, and you can see the giant amount of urban sprawl that has grown up there around Miami. And we have examples like that, all over the globe. Another thing that I did kind of as a follow-on of my dad's work is on my dad's shuttle flight, he took the first amateur radio into space. And so therefore it was also the first time that astronauts in space spoke to the general public all around the globe on their own, directly, so to speak. And so since I was flying on, literally the 25th anniversary of that first communication from space, and being my dad's son, I couldn't very well go to space without doing ham radio stuff. And but I wanted to kind of one-up my dad's thing a little bit. So in addition to taking voice communications, I also took up a slow scan television, handheld slow scan television device, and sent down images from space. But I also, while I was setting up, I knew that I'd be busy. There'd be a lot of times I wouldn't be able to be at the radio to talk to people. And so I also took up a little slideshow to be able to run when I was not able to be there personally. And so it was really kind of funny that like the top row of the things that I sent down first before I ever got to the radio. So I'd sent like test patterns to imply coming soon, because I'm sending all these test patterns. And also on this pirate flag, I actually had the program would let you put a text overlay on the image that you transmitted. And so I put Richard Garriott's mutiny on the ISS. And I got to tell you, I raised more than a few eyebrows over at NASA when I was transmitting all these hypocritical kind of things from space. I also did other commercial work. For example, I was telling people about this the other day. This is Seiko has a new watch technology that they specifically made this new spacewalk watch, and we're looking for someone to take it into space. So I took it for them, and by good chance, it turns out my father took Seiko watches for our whole family when he went up on Skylab, because that's when they invented quartz crystal timing. So they were the very first ever accurate watches invented by Seiko, and so Seiko was very proud to have me as their poster child for taking their newest technology into space, like my dad had done previously. I did work for DHL. I did work for my own computer game company. I did a lot of educational outreach. Worked with the British National Space Centre in the UK, which turns out where I was born, so I'm actually a dual citizen. And in the States and globally, really also worked with the Challenger Learning Centers. And I performed a great deal of experiments at the behest of children around the globe. And I also just did a lot of what I call just answering Q&A from space. And if again during the Q&A, I'll try to ask you some of the, I think, really good questions that kids ask that stump most adults. They probably won't stump you guys because you guys are already so space knowledgeable. But I am kind of curious, so remind me at the end. And in addition to bathroom stories, if you guys are willing to be tested, you could have a student test, see if you guys are smarter than a fifth grader, so to speak. I also volunteered for a bunch of NASA, ESA, and Korean research. For NASA, I was telling people about the first person's ever flown with laser eye surgery, corrective laser eye surgery. And that's now been approved for all NASA astronauts to have, but I'm the first person who's now flown with it. Bone density studies, visual acuity tests, immune suppression tests, a sleep study, a lower back pain study, intraocular eye pressure study from the Koreans, a psychological study for the Russians. So I'd also volunteered for a whole slew of research. And what's interesting about that is that a lot of that research, like say the bone density research, is something that the researchers at NASA really have to rely on volunteers. Even amongst the professional astronauts, they have to find volunteers to do it. Because some of those studies you take medications or other things that could interfere with your performance on orbit. And it turns out that they have a hard time actually finding volunteers. And so private citizens being willing to be guinea pigs actually is extremely valuable to these researchers, because it turns out to be hard. First of all, the frequency of anybody going to space is still pretty low, and a lot of those people opt out of many of these experiments. Some of you may have seen some of the magic tricks that I was doing the other night. Me and Greg Chamenhoff are both amateur magicians, so we did a whole magic show while we were in space. In homage to my mother, I made some art in space that we're going to be auctioning off for charity, and I made the first ever science fiction movie ever made in space. In addition, for those of you who saw the movie, first of all, raise your hand if you saw the movie, the sci-fi movie. Okay, so you remember my mother had a cameo appearance, in the movie, and that was also designed on purpose because my dad, when he went up on Skylab, took a tape recording of my mother and had a Capcom at NASA in on a practical joke where my dad could play this tape of my mother from Skylab that made it sound like my mother had gone up to Skylab to visit my dad, and the Capcom knew how to react to keep pace with the script. And so I made a similar, technology's advanced, so I made a PowerPoint, and it made it to make it sound like, my mother was up on the station with me. And I had her reprieve, a similar kind of practical joke. This is kind of the punchline.
Listen, I've been delivering meals to near-Earth orbit for nearly 30 years. I brought my famous home cooking up to Skylab, and that was probably before you were born. Now my boy's up here, and I'm not going to let him go without a good hot meal from his mama.
And so I played that practical joke on the Russian mission control, like my dad had played it on the U.S. mission control. But sadly, eventually it does. 10 days goes by mighty fast. It's one of those things where if you ever get a taste of this, by the way, going once won't be the end. It won't satiate your desire. It will only inflame it. But even after I threatened many times to stow away, the crew eventually did manage to squeeze me back into the craft to go home. What's interesting about departing that I didn't realize until we were close to the end of our training was that due to orbital mechanics, you dock from below onto the space station, but they don't want you to undock below, because if you fail to ignite your engines, and once you go half an orbit of the Earth away, you will have switched positions, which means you will crash into the ISS. And so they actually gimbaled the entire space station over 90 degrees before you undock, so that you undock in the aft direction. That's what you can see, is you can see the Earth's horizon because we're backing away from the station from behind. So in my mind, I was thinking about all those microgravity experiments inside that have all just been turned at 90 degrees. But apparently it doesn't matter. It must not matter too much anyway, since they do it with regularity.
Is that done with thrusters or wheels?
That's done with wheels. They just torque the gimbals over. You may also know, some of you may know that the previous two Soyuz reentries before mine had a problem caused by an incomplete separation between the descent module and the instrument compartment. So, this is the periscope between the commander's legs. We began with a habitation module here on top, and this is the descent module, the heat shield, and the instrument compartment with normally has solar panels sticking off of it. That when they separated, there was one latch that failed to detach, and that caused at least for a period of time, the reentry to come in nose first, which is not the way you want to come in, since it's not with your heat shield first. And it did things like burn off the antennas, so they lost communication and some other things too. But that truss is actually made to burn through. So even if you have no separation at all, the truss will burn through first, and then the thing will right itself and re-enter normally, which is what it did. But at least on mine, they were somewhat concerned about it, so they'd actually gone out on a spacewalk and removed that particular latch to make sure that it couldn't have a problem. But so we actually did have quite a smooth reentry. We did have, for those of you who saw my reentry video, which if you haven't, maybe I might be able to show it to you here again today if you guys are interested. We did have some malfunctions, including I had a 3-liter bottle fall off come undetached from the ceiling of the Soyuz above me and get lodged between my helmet and the window. We had smoke come pouring into the cabin once we dropped the heat shields, so I'm not really sure what that was, but it didn't cause any problem. And then, when you do land in a Soyuz, it is one heck of a, whump. I'm not really sure what the velocity is, but it feels like a 20 or 30 mile an hour car wreck into a brick wall. And but you're in a perfectly form-fitted seat, and the seat is on shock absorbers. So even though the violence on the vehicle is astounding, but you actually are quite comfortable through the whack. And then just like it takes a few days to adapt to zero-G, it takes a few days to recover from zero-G. My dad, by the way, was my chief scientist through this whole thing. He helped me put together my whole science program. He was there at the base of the rocket when I boarded it. He ran my mission control team throughout the flight, and was here, at the landing site too for recovery. And now, I kind of alluded to this with some of you that I talked to personally over the weekend. this is probably my biggest takeaway from going into space, and why I think that humanity would be greatly served if even 1% of us managed to get off the planet and get the chance to orbit the Earth a few times. Not just a suborbital flight. What I'm about to show you is why I believe orbiting the Earth for a period of a few days or more is a truly life-changing event. And of course, it's hard to impart that into you without sending you all on the trip. So I hope you get a chance to really go on the trip, but this will be at least an attempt to provide that a similar kind of understanding. Of course, seeing the Earth from space, of course it's a beautiful view. But there's this series of epiphanies that you go through kind of each day, or each time you look out the window, another little piece of this puzzle kind of gets built in your mind. And so it's like I would describe it as like a fire hose of information that is just pouring into your brain as you go past the Earth at 17,000 miles an hour. And as you guys know, you're going to see a sunrise or a sunset every 45 minutes, and you're going to cover from like the west coast to the east coast of the United States in just 8 minutes. And so you're really, really booking. So the amount of data that you're picking up by just looking out the window is amazing. And one of the first things that you really think about is what I'll call the Earth goes from being this arbitrarily large space. I mean, we've all seen a globe, we've all flown long distance on an airplane, but when you see it from space, you really go, the Earth is no longer an infinite or an unknown amount of total geography. It is now completely finite. And the place for me that became most true is when I could see places I knew intimately. Houston, Austin, Dallas, the Gulf Coast, and a little bit of Florida. Those are things I've all driven in my car with some regularity. So I know that distance intimately. And then you can see the rest of the Earth. And so you go, at that moment you go, I now know the true scale of the entire Earth by direct observation. And it just kind of strikes you. You just go, I get it. I now know the size and of the full Earth. And the same thing's true, especially for the atmosphere, where you look out at the atmosphere and it is so thin. You're only 250 miles up, but when you think about the altitude that 50,000 feet or so that airplanes fly at, the atmosphere. This, of course, is a zoomed-in shot at sunrise or sunset, and you can see that only about 10 times higher than the clouds, the atmosphere is so thin it no longer refracts light. I mean, clearly there's some air that goes up, some molecules that go up quite a ways above that, but it becomes basically a vacuum pretty shortly after. Not much higher than airplanes fly, and you're into this scant bits of nothing. And when you see things like fires on the ground, even a simple fire like a house fire, you would see that it would fill the entire air column from the ground up to basically space, or close enough, and then spread out over entire states or more. And so it would just strike you going like, wow, there's really just not that much air around this entire planet. And it becomes quite easy to conceive how pollution or other human factors, or even natural factors, can easily put particulate matter that would occupy a significant chunk of the totality of what you can see. And what's interesting too, though, is that when you look out at the horizon, you felt very high above the Earth, but when you look straight down, as most every window faces on the ISS, it actually looked very familiar. I mean, you would see clouds and airplane contrails and things that look not that dissimilar to looking out the window of an airplane. And if you look down at areas that were really familiar, you would see really astoundingly familiar things. Like, this is now looking over San Francisco. There's the Golden Gate Bridge, the Oakland Bay Bridge. Here's a ship and its wake coming in and out of the bay. Golden Gate Park. There's Alcatraz. All of these things that you can see out the window of an airplane again, you can see out the window of the space station. I mean, I was just stunned how much of that stuff you could see. In fact, the one really notable thing you can't see from space is the Great Wall of China, which I grew up always hearing that's the one thing you can see from space, and you can't not see it from space, but almost anything else you can see from the plane, you can see from space. But then as you travel around the Earth, one of the things you learn a lot about is what I'll call the large-scale systems of the Earth, especially things like weather. Weather was one of the first things you begin to feel like you understood, because about half the Earth is generally covered in weather. And so you would see things like these over the Pacific Ocean. I would often see these giant laminar formations, largely able to be formed because there's no land masses or other things that kind of interrupt their growth. Whereas when you would get over areas like the Gulf, where you have the shallow, hot water, and you would see all these storms brewing, and the hurricanes would grow out of those regions and things too. And you kind of go, as you go around the Earth, and you'd see about half the time you'd see clouds, you're going like, hey, I get it. My just intuitive understanding of meteorology has gone way up. The first land you see a lot of is deserts. You see a lot of the results of eons of tectonic plate movement. You see the results of eons of water erosion. You see the results of all these eons of wind erosion that I had no idea could create these formations that are thousands and thousands of miles across, all created by consistent winds of one direction over just enormous timescales. And but one of the things that didn't hit me until I'd gone around the Earth many times is that every fertile part of the Earth that I ever saw from space is completely occupied by people. There was no place I ever saw from space that I would describe as a giant unoccupied wilderness. I mean, there might be some in northern Alaska or something that I never got to see, or some of the northern parts of Canada that I didn't fly over. But as a general rule, every fertile part of the Earth I ever saw was completely occupied by people. Even up in the high alpine areas, if you look in those little valleys, you'll see roads and dams and the signs of human habitation. Even out in the vast deserts, all the deserts are crisscrossed with roads. And I just happened to look out the window one time, and you can just look down and see the Palm Islands in Dubai. And it's just astonishing that we are terraforming the Earth at such a scale that is so easy to see from space. And here we are out in some of these vast deserts, and you can see those are some of these circle crops. This is an old ancient riverbed that they're pumping up groundwater to grow these crops. And I know obviously you can see these rows of crops, but I don't know if you know you can see there's a set here, there's another set here, 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 and then they pick up again over here. So think about the cost of growing food out here when you're having to do that kind of water reclamation, and there's no city or town anywhere nearby. I have no idea how far away they're trucking this food to someone. And I'm going, we're just spending an enormous amount of money. It's pretty cheap to grow crops in a piece of fertile, land outside the back door here. But we're now, as we occupy the more and more difficult places of the Earth to survive, these costs have to keep rising. And I remember my father telling me stories about seeing fires burning all throughout the Amazon. And sure enough, every time I went over the Amazon, the entire central portion of South America is covered in fires. Same thing's true for the fertile band across the center of Africa, covered in fires. And this has been true for all 35 years that we've had people traveling in space, is that we've basically been constantly burning off the forested areas of those countries. And so I have to tell you, that those were all what I'll call subjective opinions or impressions I got from traveling in space. That inspired me to come back and go like, okay, well, what does the objective data say? And we've got great satellites that do a great job of measuring what I'll call human impact on the surface of the Earth. And I'm sure you won't be surprised to find out that in fact the impression you have from space is actually pretty accurate. The objective data actually says basically the same thing. And to me, that at the very least implies that even if we're not at some giant cliff of environmental catastrophe, which I'm not trying to say we are, but at the very least, the cost of existence is now, it must rise. I mean, we really are, the easy to exploit areas are a thing of the past. We're now on a steady march of doing things that will become more and more expensive. And so that really has inspired me to, to both be on a personal level as well as be an evangelist for, what I consider, good environmental causes. And I can go into those, what I'm doing in my personal life separately if you'd like. Another thing that I gained from my trip to space was a real appreciation for Russian space history and Russian engineering discipline, things of this nature. You guys probably all do know this, that, other than landing a person on the moon, pretty much every first there was to do in space, the Russians did it first. And, if you go look at space history books in the United States, they almost always they claim they're space history, but they're really American space history. And almost no museum in America that has a section about space includes the Russians. But by the way, that's not true in Russia. You go to Russia, including on the Gagarin Cosmonaut Training Center in the former secret Soviet base, great selection of Gagarin and Neil Armstrong statues. They celebrate our space way better than we ever celebrate theirs, which I think is an odd juxtaposition of our land of the free. I obviously didn't quite finish this slide. You know, when you talk about engineering safety, you know, one of the things the Russians have done very well is iterate. You know, here is the vehicle they used to launch Sputnik, and you can see it has these 4 strap-on first stage boosters and a central core all the way up to here that they call the second stage, which fires really at the same time as the first stage, but the first stage kind of falls off first. And then only in that very top cone, actually that second stage goes all the way up just below that cone. And in that top cone was the Sputnik with its 4 antennas actually folded up into that point. Well, then when they sent Yuri Gagarin up on the Vostok, you can see that the first stage looks the same, second stage ends about the same, then there's that little separation truss, and then there's a third stage prior to the ball, the thing that he was launched in. And if you look at a modern Soyuz, first stage looks the same, second stage looks similar, third stage looks taller, and then below that white fairing is the orbital module that I showed you a picture of earlier. And so it's very easy for Americans to look at that and go, oh look, you know, they just haven't really changed anything in 50 years. And while there are certain aspects of it that are clearly extremely hereditary, you know, as these move forward, they build, you know, about 2 at a time of these things. It might be up to about 4 at a time now that they're increasing their frequency. I don't know how they're doing that actually. But after each run, they go back and review the entire production line and make as many improvements as they deem is appropriate. And by that slow and steady iteration, they've increased the capability of this machine, they've increased the safety of this machine, they've decreased the costs of this machine. And so, you know, if you're going to go to space and you want to do it cost effectively and safely, which are the 2 hard things to do in space, this is by far your best ride to space at the moment. Which brings me to, so these are the slides now that I've, you know, created based on, you know, discussions with you all here this weekend. You know, I actually think one of the biggest problems we face is that human spaceflight today is not a compelling taxpayer investment. We have not made a good case for why taxpayers should be funding even the 0.5% or 1% of what we're doing in space. And so I understand, appreciate, and can relate to, you know, what I'll call taxpayer apathy towards the space program. And to me, the problem looks something like this. You know, we've spent 20 years, $100 billion to put the ISS in orbit. We spend $2 billion a year just to not splash it. And it costs us somewhere between $300 million and $1 billion per astronaut to go there and do anything. And, you know, if I had to sit down and go, okay, well, what science is so important or so valuable that it's worth that cost to go do? And in my calculus, the answer is not much. I mean, I'm not sure what it is other than a jobs program, and it's kind of cool to have up there, and I sure appreciated getting the chance to go. But as a taxpayer, I think it's a hard case to make that that's a good investment. And so one of the first things I would do if I were emperor of NASA is I would make the space station, since we have it, I don't think we should splash it, I think we should keep it up, but it's still so expensive for people to go to, and there's so much red tape for them to get there to try to do anything, that there's a real risk that it won't be utilized. And so the first thing they need to do is make it free to anybody who can actually pay the launch cost to get there and utilize it, unlike for me with, say, or other people or other countries or universities where they try to charge an arm and a leg to utilize it once you get there. They just need to make it, if you can get there, it's free. Because it really is one of the best science labs you can possibly imagine. It's a phenomenally capable facility, but we've got to encourage people to get there, and one of the ways to do it is to make it freely available. But more importantly, I think that the cost of access to space must drop, and importantly, can drop. You know, almost every other mature transportation method only costs about 3 times its energy. So for cars, planes, boats, trains, they all cost about 3 times the fuel cost to operate. And the only exception to that is space, where it costs about, 500 times the fuel cost to go to space. And there's no excuse for that. I mean, it is clearly a harder place to go, and so it may not be able to get down to 3, but but there's really no need for it to be up as high as it is. And the Soyuz is a good test case where, to launch the entire Soyuz costs about $200 million. It's the cheapest way to put 3 people in space that exists right now. But the fuel cost is less than $1 million of fuel. I think it's only a few $100,000 of fuel inside that thing. So if you were to call it $1 million in fuel, triple it, that'd be $3 million. That would be $1 million per person if you could get it down to that 3x. And by the way, most of the people doing private space flight believe they'll get close to that. Most everybody who I know is in the commercial side believes they can eventually get, in a couple iterations of orbital vehicles, they can get it down to single-digit millions per person for the cost of access to orbit. And if we can reach that goal, that is completely game-changing. Because, for example, I tried to do commercial work in space to offset my horrible price I had to pay to go to space, and I by no means made a profit on my space flight. But I did earn millions of dollars towards my tens of millions of dollars of space flight. And so if we get the cost down to millions of dollars, we can all go to space. Not because you have the money in your pocket, but because space will pay for itself. And that's ultimately what we really have to do with space, and I believe we can. I believe you guys can. And so that's why I think that commercial space flight has a huge role to play. I believe that NASA will be able to then focus on pushing the veil of humanity, or pushing humanity off into space, help research radical new technologies, space elevators or other things that private industry may not or couldn't tackle, but then hand off or encourage the development of commercial to do everything in not just low Earth orbit, but I believe even lunar and the big parts of even what it takes to go to Mars. I think that just like you have the Google Lunar X Prize, I think we expand things like that into bolder and bolder statements that take us farther and farther away. And then my radical plan that most people don't like is that I think that versus take the slow boat to Mars, which Charlie Bolden has come out and said, hey, he wants to see us get to Mars within his lifetime. I actually think our current strategy won't achieve that because I think it'll take us 20 to 30 years to get back to the moon, and then another 20 or 30 to get back to Mars, and a lot of us will be dead by then. And that's only if we manage to keep the political will to sustain it. I'm a person who goes, I think going back to the moon is great, but I think that we should push that largely onto commercial, or do that as a side benefit while we clearly set the targets on Mars and figure out how quickly, and if not Mars, a near-Earth object is actually fine too. I just mean we should set a new target and proceed as quickly as possible towards really pushing back the boundaries of humanity into the universe, at least into the solar system. And so, in closing, my closing comment is, for all of you guys, I know you guys get it, that you guys, you've heard plenty of speeches where, you guys are the future of the world, or at least the future of space in this case. I know you all fundamentally get that. I mean, you wouldn't be members of SEDS if you didn't already understand that you guys are going to be very soon taking over the reins of space policy and space industry in this world. I presume it's not lost on you guys already that the early SEDS members, what we'll call Peter's class of early graduates from SEDS and ISU, already occupy a significant percentage of the commercial companies' upper ranks. A significant percentage of the NASA hierarchy is now infiltrated by SEDS folks. And that percentage, I think, will continue to rise as you guys take over the world. And so my advice to you is not to convince you that you are the future, because I think you get that, but really is to say, look, you guys have to master these three critical areas concurrently to chart the proper path out. One is you clearly have to know the technical problems that need to be tackled. And if you're in the aerospace side of education, clearly that's kind of the fundamental piece you're picking up already. But you also need to learn what I'll call the commercial problems. You all need to be good entrepreneurs. You need to be well-qualified entrepreneurs. You gave a great entrepreneurial speech the other day. So I don't know if those are the kind of things you can get in a class. Find a way to get this to read. You have any books out or something? Find a way to read up, and you all need to be competent commercial developers and entrepreneurs. And then an equally big piece is you have to understand the political realities and figure out how to work with the Commercial Spaceflight Federation folks who are doing a great job lobbying over in Capitol Hill. The amounts of money we're talking about are so large that politics has to play a big part of it. And so that's just a reality of this whole thing. So even if you have a great idea and you're a great entrepreneur, if you don't have the government behind you, you're still going to have trouble. And so you guys have to navigate all three of those problems simultaneously amongst you. And so learn this material well. But I personally have every faith and confidence you guys are going to do a great job of it. I personally am very inspired by getting to hang out with you here for the last couple of days. So thank you very much. left too, so if you have any couple questions.
There's
Story?
I got a comment and a question, or comment and a question.
Sure.
You were talking about iterative development on the Russian side, and as a counterexample to that, my wife Andrea, who was also a SEDS member at the U of A, after college she went and worked for Thiokol up in Utah, working on the shuttle rocket boosters, and they would frequently find ways that they could improve it and the fuel grain and make it better, and they were under specific contract not to. Their charge was to keep it exactly the same as it had been in 1977 when it was first designed. You know, even if they could make it safer and better, they couldn't.
Right.
So that's kind of how NASA works.
Yep.
The question was, on your eye surgery, is there any particular type of eye surgery that you had that was approved, or is it any eye surgery that you could walk down on the corner of the street that the shop pros that is approved?
Any of the laser eye surgeries, photorefractive eye surgeries are approved. The one that would not be approved is the one that's not really done anymore with the scalpel where they do the radial cuts. But any of the laser ablative versions would be quite successful, quite accepted. Yeah.
So you had a picture showing your launch in the Soyuz, and there was a little guy standing down there
Yeah.
in the corner. How far away was he?
So that's another fun thing. That's another fun thing about Russian launches is that unlike in the U.S. where lots and lots of people go out to the launch because it's it's within the continental United States. In Russia, out in the middle of Kazakhstan, there's really not that many people. And since there's not that many people, there's also not that many safeguards. Because everybody who's there is, generally speaking, technical team involved in the launch. And so, if you're one of the people who doesn't have a responsibility but is also there, you're actually fairly free to go wherever the heck you want. And so the first launch I went to, which was Greg Olson's launch, I stood 200 meters from the base of the rocket as it launched, which is about where that guy is. And so literally you're standing well within the kill radius. And and the assumption there is that, hey, you know it's dangerous. Don't go stand next to it if you don't want to get killed by it. But it's funny that even the review stands are only about, where your family and friends would be, it's only about 800 meters from the rocket. And so everyone is stunningly close. In fact, the launch, the launch control in Kennedy is about 3 miles, 5 miles, away. Launch control is right at the base of that rocket. You can't quite see it, but it's basically right here. There's a bunker that's right here in a little recessed valley right beside the pad, and that is where the launch control is meters from the bottom of that rocket. And by the way, some of them have come down, crashed right there on the pad. Some of the Progress vehicles have not lifted off and blown up, but they're all bunkers, so everybody survives fine. Yeah.
Got one quick one and one longer one. Where's your spacesuit kept? And 1,000 years from now, what do you want your legacy to be when people kind of think back about things that you've done and things you will do?
Well, it's funny. My spacesuit, it's actually on my living room couch, just lying there. And the reason why is I actually have another spacesuit that I bought some years ago, but it's on a stand. But to put it on a stand, you have to grip it in some way with a holder, which inherently means you're damaging it. And so, on the off chance I get to use my spacesuit again sometime soon, I'm not willing to, risk modifying it in any way, or rubbing on it or anything. So actually, literally, just have it laying on the couch, and because I don't want to even fold it up because I don't want the rubber to, get any, kinks or anything in it too. So it's just laying there, hoping to be reused. And from a legacy standpoint, that's a good question. I'm not really sure because. If I had an answer for that in the games industry from the gaming side, which is that, I was lucky enough to start fairly close to the beginning of games, but as you guys know, probably understand that unlike the book industry, where if you write a great book, it will survive for a long time, but the probability of writing a great book compared to other great books is actually pretty low. In the gaming industry, it's actually pretty easy to write the best game ever written because there haven't been very many, but the machines don't even exist to play the first 10 games I wrote on. And so even if they were at once in their time the best game ever written, they're already long forgotten. And so in the gaming industry, I've always thought, that I hoped that I would have a long enough history of contribution at a high enough level of contribution that people playing what I'll call the sequels or the games that were inspired by my games could reflect, upon the quality of the contribution I made early on. But in the space area or in my exploring side, I really don't have an intended legacy yet. Good question. Okay, 2 more questions. I'll do the bathroom as one. I'll take one more question, then bathroom. Yeah.
What's your next gaming project?
Officially I don't have one. Unofficially, I have a small group at my offices on my property, kind of doing some research. But it really is just a ponderance at this stage, and kind of just seeing what I think I might want to do. So we'll see. So the bathroom story. So what's funny about going to the bathroom in space is how you train for it, and then how it really works. So the training for the toilet goes something like this. Let me bring up the toilet picture. There it is. So the toilet is designed where there is this tube up here with a little yellow top kind of going on the side is the urine collection device. And then this is the solid waste receptacle. And by the way, this is the only wood that exists on the International Space Station, the toilet seat. And and basically the way when you power this thing up, it's complicated to turn on and off. They've got all these controls over there. You can't just use it and flush. It's fairly complicated. But once you learn that, you've got it. And liquid waste is not a big deal. You basically pee into the funnel, and there's a vacuum cleaner basically into the side, so there's airflow that pulls it in there. And there's a round funnel that's attached there for guys, and they have a little lozenge-shaped funnel for girls, and close enough, it works. And the solid waste receptacle has a similar theory. There's the same vacuum hose that's connected to basically a beer keg. And on top of that beer keg is this shoebox-sized toilet seat. When you open that toilet seat, in the center of it there's a Coke can-sized hole, receptacle, in which you put a plastic bag with a rubber band that holds it at the top of the hole. The plastic bag goes down inside the hole, and there's perforations in the bottom of the bag. And the theory is that when you sit over this toilet seat and send solids out of view, airflow will pull them into that plastic bag. When you finish your business, you pull the rubber band off the top, that plastic bag self-seals, and it falls into the beer keg. And when the beer keg, after 2 or 3 days, is full of little plastic bags of poop, you seal up the top, you disconnect it at the bottom, you eject it into space, and make a shooting star. And put a new keg in here, of course. And by the way, that's basically the beginning and the end of the training. That's how you're told it works. Good luck. So here's the real problem, however. So I'm going to use a metaphor to describe the problem. I'm going to use toothpaste. So here on Earth, like this morning, when I woke up and went into the shower, or went into the bathroom to brush my teeth, if you were to take a tube of toothpaste and squeeze it over the sink at your home, toothpaste will come out of the toothpaste tube, curl down towards the sink, and eventually enough will come out that gravity will take over and pull it off of the container and plop it into the sink. Well, if you do the same experiment in space, you will squeeze the tube of toothpaste, a few inches of toothpaste will come out and stay there. If you stop squeezing, it will just stay there. If you start squeezing again, you'll get some more out. If you try to pull the toothpaste tube away, it will come with you. Right? That's what will happen in space. You agree? Get it? So now, another important thing to keep in your mind about going to the bathroom in space is that your GI tract really slows down in space, because on Earth, when you walk around all day, it helps your GI tract move. So in space, if you go to the bathroom, say, once a day on the ground, you go to the bathroom about once every 5 days in space. So when you gotta go, you really gotta go, okay? And you got a lot to go, okay? So now here you are, you're going to the bathroom, you go, okay, it's been 5 days, time to go to the bathroom, all right, we're gonna figure this out. Go in here, close the door, power the whole thing up, get ready. Well, in about 1 second, you will create toothpaste of sufficient length to go from you to the bottom of the plastic bag. So you stop. And you go, oh, well now what? Because no one's told you about this moment. But you go through this in your head, you go, like, if I stand up, I'm going to bring hazardous material into the room with me. So what do? And it turns out everybody invents the same solution, which is you basically do this little bounce maneuver, which kind of breaks things off of you so they'll fall in the bag. And that works. And it's actually named after some astronaut that was the first guy to invent it. I forgot the guy's name, but it even has, the maneuver has a name. But again, they don't tell you this until afterwards for some reason. But now you have a new problem, because don't forget this is a Coke can size insert, and it now has an obstruction in it. A diagonal obstruction in the middle of the bag. So if all you do is start up again, you're going to have the exact same problem you had a minute ago, but much sooner, almost immediately. And so you go, okay, well, what am I going to do about this new problem? Because I've just started my business, and I can't just continue my business, or it's just not going to work. And so you think, and you think, and you think, and you think, and everybody invents the next solution, which is manual manipulation. So you get out wet wax and or rubber gloves or anything you might wish, because you have to now make room in the bag for you to be able to continue your business without interacting with the already pre-existing obstructions. And so you actually have to repeat this behavior over and over again until you finally manage to finish your business / use because you don't want to, you couldn't just use bag after bag after bag, because you burn the supply of plastic bags up, if you know what I mean. So it takes you about 40 minutes just to go to the bathroom. And then finally, you finish your business, you clean everything up, you put it all away, you get out of the bathroom, and then you go over to your other cosmonaut buddies who've already been up there for 6 months and go like, why didn't you tell me? And it's like, everybody figures it out. And so, but you can go, like, there's even books published, like How to Go to the Bathroom in Space. They will not tell you the story I've just told you. It's really funny that the astronauts are so stoic that they won't even share this incredibly important piece of information about personal hygiene in space. But anyway, thank you guys very much. Sure appreciate it.